All right. Hello there. So today we're going to talk a little bit more about absolute value functions like we did in class today. So go ahead and title your notes absolute value functions. And this is unit 1. So I guess I would put that beforehand. Sorry about that. All right, so absolute value functions. Remember today in class we talked about absolute value functions. That's when you had like y equals absolute value of x. And so everything turns positive. And so you have your original graph, just like we did in class. So if you want to take a second and draw like a little absolute value graph, or draw yourself a little set of axes here. Remember, when you plug in 0, you get 0. When you plug in 1, you get 1. And we did our table in class today. So this is like your basic absolute value function. Goes up like that, and we talked about, and it goes, if you plug in -1 into here, you get +1. If you plug -2 into there, you get +2. And so we talked about how this graph here goes just like that. All right, so some things to note about this. So it has a V shape to it. All right, so V shape, and it's facing up, or opens up. All right, and also the slope of each side. The slopes are plus or minus 1. So like this part over here has a slope of 1. It goes up 1 over 1, up 1 over 1. The left side has a slope up 1, back 1, up 1, back 1. So that would be a -1. All right, so that's going to be important for some stuff we do next class. All right, so let's talk about some transformations that you could have on these functions. So second example, or I guess, whoopsie. Example 1, I guess you could say. Let's say we had an equation like this. Y equals absolute value. And I have x minus 2 inside the absolute value bars. So we're going to start off by making a little table here. So x and y. So let me first pick something that would make that equal to 0. So that would be a nice thing to pick. I'm going to put that kind of in the center. So 2 would make that 0. 2 minus 2 is 0. So 2 minus 2, if I plug 2 into that, I would get 0. So let's pick a couple numbers before 2 and a couple numbers after 2. So how about let's pick 0, and how about like -2, how about? So if I put 0 right into here, 0 minus 2 is -2, and the absolute value of -2 is +2. So I would get 2. Now if I plug -2 into here, -2 minus 2, let's see, that's -4. The absolute value of -4 would be +4. All right, so let's pick some numbers after that. So how about 4 and 6? So I'm trying to equally space them out so it'll kind of like look nice when we're done. But let's say we put 4 in here. So I'm putting a 4 right here. 4 minus 2 is 2. So the absolute value of 2 is 2. So I'm going to be putting a 2 right here. And when I put in 6 up there, I get 4. All right, so let's graph these points. -2, 4, 0, 2, 2, 0, and then I have 4, 2, and then I have 6, 4. So look at that. It's the same absolute value bar, or absolute value shaped graph, same as the last one, but this time it's moved 2 spaces to the right. So we have what's called a transformation. We have a transformation, and what's happened, it has moved right 2. Because back here, this was our parent function. This is our parent. And our little child here looks like our parent, but it has moved 2 spaces to the right. So it's been transformed. All right. So now we're going to do one. And we're not going to draw the table on this one, but we're just going to try and, if we can imagine what happens. So in this one, let's do y equals absolute value of x plus 3. Okay. So imagine to yourself what would make that absolute value come out to 0. Well, if you put a -3, that would make it 0. So if I plug -3 into this, I would get -3 plus 3 is 0. Absolute value of 0 is 0. So that's how I'm always going to be able to figure out a little bit like kind of like where the center number is on these two right here. So this one moved to the right 2. So this one's going to move to the left 3. So that's going to be my transformation. And it should make sense to you. If a -2 moves you to the right, then the +3 moves you to the left. Okay, so it seems a little odd, but if you made a table, it'll work out. So I start at -3 because it's moved over from the center. It moved over 3 spaces. Okay, and then my little slope here, up 1 over 1, up 1 over 1 on each side, and up 1, back 1, up 1, back 1, up 1, back 1. Okay, so remember that when you have a number inside the bars with your x, it's moving it side to side. So inside, side to side. Okay, inside the bars moves you side to side. And it's kind of weird because it's like the opposite of what you would think. So for example, we're not going to draw this one, but if I had y equals x minus 5, that would move me to the right, move my parent right 5 places. If I had y equals absolute value of x plus 2, that would move me to the left 2 places. Okay, so those are left and right motions. All right, so this next one right here, let's see what would happen. So we're not going to put anything inside the absolute value bars. Let's see what would happen just this one time if I put like a +3 on the outside. Okay, all right, so let's just try some numbers here. All right, so let's try like, how about I'll do 0 and then a couple numbers before, like -2, -4, and then +2, +4. Okay, all right, so -4. If I put a -4 right here, so absolute value of -4 would be 4. I'd get 4 plus 3, so I'd get 7. All right, so now I'm going to imagine I'm going to put a -2 in here. Absolute value of -2 is 2, and 2 plus 3 would be 5. All right, then put a 0 in there. Well, 0 plus 3 is 3. All right, then I plug a 2 in. 2 would stay the same, so it'd be 5, and 4 would stay the same, it'd be 7. All right, so when you graph this, we got -4, 7. Oops, a little bit off my graph, so I'm going to go up here. -2, 5. Okay, then 0, 3. Then 2, 5. And 4, 7. All right, so look at that. So look what happened to my parent function. When I added a number on the outside, it moved me up 3, or up that amount. All right, so let's just do one more of this, and we'll start to like piece it all together. Let's say, for example, I had absolute value of x, and let's say I put a -2. So based on our last thing that we just learned, this one was up 3, so guess what? This is down 2. All right, so down 2, so means my center is now right here at -2, and my right side goes up 1 over 1 as my slope. My left side is up 1, back 1. And I just, oopsie, well, that was kind of ugly. All right, well, you get the idea, right? I'll see if I can erase it. Excuse me. All right, so it doesn't have to be awesome or anything, but you get the idea. All right, so for example, let's say I had the y equals absolute value of x, and then I put a +4. Tell me, what would that do to your parent function? Tell me in the Edpuzzle. All right, so hopefully you told me that it would move you up 4. Okay, all right, so now we're going to have a combination of the two. All right, let me see where I am here. All right, so let's say we had, for example, let's put a couple of these together. Let's say we had absolute value of x plus 3, and then I have a -1. All right, so based on what we knew from before, the inside moves me side to side. So remember, the inside part is opposite of what you think. So this is going to move me to the left 3. And I mean opposite because you see a plus there and you're like, oh, that seems positive. That's to the right. No, it's to the left. And this guy is going to move me down 1. So you guessed it, I'm going to take my point right here and I'm going to move it to the, I would move it to the left 3. So 1, 2, 3, and move it down 1. So it's going to be right here. So I'm going to erase what I drew over there and put it right where this big white dot is. All right, so left 3, down 1, there it is. And then the slope on either side is up 1 over 1 and up 1, back 1. And there's my V shape. Now that slope can change sometimes. We'll talk about that next class, but right now we're just doing the basics. Okay, so I want you to tell me in the Edpuzzle what you think is going to happen to this. If I put absolute value of x, I put -2, and then I put -5. What direction do you think I'll have to move that center point? All right, so hopefully you said you'd move it to the right 2 and down 5. Those are your transformations to your parent function. All right. Okay, so now we're going to go backwards a little bit. This time I have a graph right here. And I have a graph and it's been moved already. So now I want to go backwards. Now I want to know what is my equation. What's the equation of this function? Well, I notice it's been moved to the left 3. So my equation is this. I need to put some numbers inside because I moved to the left or right. I moved to the left. So I need to put a number with my x. And so I would say it's moved to the left 3. I would want to maybe put negative, but remember in the inside it's the opposite. So I put +3 and I'd be done. All right. Over here, I want you to tell me in the Edpuzzle, how do you think this thing has been moved? Like it used to be the parent function. How was it moved? Okay, so hopefully you said it was moved to the up 2. So my equation that I want to write for this is y equals, the absolute value just has your x because it didn't move left or right. So up 2 means I put a +2. So everything's raised by 2 points or 2 spaces. All right, and this next one moved down. So my equation, see if you can pause the video maybe and write the equation. All right, so hopefully you wrote x, absolute value of x, then put -5. All right, so this one, I want you to tell me in the Edpuzzle how you think it's been transformed. Remember your good old parent function looks like this. What motions or how has it moved from the original? All right, so hopefully you said to the right 4 and up 1. So I have to do both of those. This is the first time we've done both of those like with this example. All right, so absolute value bar is a little bit wide because I got to move myself to the right 4. So x -4 because it moves opposite of how you would think. And up 1 is true to form, like it's up 1, so you do +1. All right, so this one here, this was moved from the center. It's moved left 5 and down 3. All right, so left 5, down 3. So my equation is going to be x +5 this time, left 5, and down 3, so -3. All right, so tell me in the Edpuzzle, or actually just don't, never mind. I'll just let you know and then we'll talk about some other stuff. So this one right here, what's happened here is you notice this thing is upside down. So a lot of people would say that the graph has been flipped. All right, so yeah, it's flipped, but in math, we want to use a proper term, so we don't want to say flipped. We want to say that there has been a reflection. And technically, it's a reflection over the x-axis. But we're just going to say reflection, all right? Because this is our x-axis, and what happened is the graph used to be up here, and it flipped over, right? And so it reflected over the x-axis. Right, like you see a reflection in a mirror, like the x-axis was the mirror and it reflected over that. Okay, so to do that, to make our graph do that, what we'd have to do is we'd have to, in our equation, so you notice everything's negative now. So I have the absolute value graph. Every answer that used to be up here is now negative. So what I have to do is put a little negative sign in front of all my answers. So put a negative sign. So anytime you see a negative in front of there, what it causes is it causes a reflection. All right. All right, so last couple things here. So 3 things happened to my original graph. So let's draw the original graph real quick, right here. Okay. First of all, here's the new vertex. Okay, that vertex is at 1, 4. So it got moved from 0, 0 to 1, 4. So it got moved to the right 1 and up 4. But then the graph is also upside down, so there has been a reflection. So these are the 3 transformations that I have to represent when I go ahead and write my equation. So let's write the equation. So y equals, so I'm going to put some absolute value bars, make them kind of wide because I got left and right motion. I know I have a negative because of the reflection. So the right 1, that's what goes inside. So I do x minus 1 and then up 4, so plus 4 would get me there. All right, and I think I got one. Oh, nope, we're done. So we will show you in class how to graph this in Desmos as well, so you can get a good idea and see how to do that. But that's it for now. I'll see you in class.